Hello everyone, I'm Ramya. Today I'm going to discuss about the topic called solving homogeneous recurrence using characteristic roots. So before going to that topic, I would like to say what is a recurrence relation. It's nothing but it is an equation that recursively defines a sequence where this is most important. The next term is a function of previous term. What does this mean? Means the next term will be the function of previous term. Here, the next term is identified based on the previous term. So let us take an example and understand it more clearly. In the example that I have taken here, s is equal to 5, 8, 11, 14 and 17. The first term is 5. The next term is 8, 11, 14, 17, so on. By observing clearly in this example, we can say that by adding 3 to 5, we'll be getting 8. And then by adding 3 to 8, we'll be getting 11. By adding 3 to 11, we'll be getting 14. And then 3 to 14, we'll get 17. In this way, the sequence goes on. So what we can say is, by adding 3 to the previous term, we are getting the next term. That means we are adding 5. We are adding 3 to 5 and we are getting 8. And we are adding 3 to 8, we are getting 11. So what can we draw a conclusion from this? We can write a recurrence relation in this way. Let us take an as next term. Okay, and then by adding 3 to the previous term, we are getting next term. So what is the previous term of an? It is an minus 1. By adding an minus 1 to 3, we will be getting the next term called an. So we can say that this is the recurrence relation obtained for the given example S is equal to 5, 8, 11, 14 and 17. So for every problem which will be given to solve by using characteristic roots, we have to find in this way the recurrence relation at last. So we'll be seeing how can we find that. So before that, we'll be knowing the general form of recurrence relation which is having constant coefficients. The general form is f of n is equal to c0 an plus c1 an minus 1 plus c2 an minus 2 so on ck n minus k, where c0, c1, c2 up to so on ck are known as constant coefficients, and then an minus 1, an minus 2, these are all known as variables. Now let us see how can we find order and degree for a given recurrence relation. So what is order? Basically it is a difference between largest and smallest subscript. This is known as order. And how can we find degree? It is the highest superscript. It is the highest superscript of given expression. So before finding order and degree, we must know what is meant by a superscript and what is a subscript. So let us take an example and know that in the example C2, here 2 is known as subscript, and whereas in A cube, 3 is known as superscript. So what is subscript in C2? It's 2 and superscript is 3. So let us take an example and see how can we find order and degree for the given equation. The example I have taken here is an is equal to 2 an minus 1 minus 2 an minus 2. The highest or largest subscript is n, whereas smallest subscript is n minus 2. So by taking difference of these two terms, we will be getting the final answer that is known as order, n minus n minus 2. So n will be cancelled and the final answer is 2, which is order of the given example. How can we find degree? In the second example, the highest superscript is called 3. So the degree will be 3 for this example. As the highest superscript of given example is 3, degree is 3. So coming to the main topic, solving homogeneous recurrence by characteristic roots. So before going to this, we must know what is a homogeneous recurrence. So in the general form that we have seen before, where if fn is equal to 0, then that expression or equation is known as homogeneous recurrence relation. Whereas when Fn is not equal to 0, then that is known as non-homogeneous recurrence relation. Coming to the topic that I'm going to discuss is characteristic roots method, which is a type in homogeneous recurrence relation. Basically, there are 4 types in this. First one is substitution method, and then characteristic roots method, generating method, and then undetermined coefficients method. I'm going to discuss about characteristic roots method. So in this, the general form is, as we are taking homogeneous recurrence relation, f of n will be 0 here. And then while finding characteristic roots, we may get some roots as equal and some of them will be different. When we get all the roots as equal, we will be writing the final recurrence relation as yn is equal to a lambda 1 par n plus b of n lambda 1 par n. Here I have taken lambda 1 par n as common. As roots are equal, we'll be taking common. So this is expression for 2 equal roots. What if we have 3 equal roots? We will be having an extra term called plus c into n square. Plus c into n square. We'll be having this as extra term, that is plus c into n square, and we'll be taking lambda 1 power n as common, c into n square. So from this we can say that when roots are equal, the constant coefficients will be 3, because how many roots we have here? If we have 3 equal roots, then the constant coefficients will be 3. If we have 2 equal roots, constant coefficients will be 2. That is a and b. As we have 3 equal roots, constant coefficients will be 3. That is a, b and c. What is the expression we will be writing? A plus b of n plus c into n square. If the number of equal roots increases, the power of n will also increase. Suppose if we have 4 equal roots, then the next term will be plus d into n cube. In this way, as the number of roots increases, the power of n will also increase. This is the case in if roots are equal. So if roots are different, simply we will be writing a into lambda power n plus b into lambda 2 power n. This is if 2 roots are different. What if 3 roots are different? We will be writing one more constant coefficient, that is c, into the third root, that is lambda 3 power n. Okay, if number of different roots also increases, we will be having one more term, that is plus d into lambda 4 power n. In this way, we will be writing recurrence relation expressions for roots are equal and roots are different. Let us take an example and understand it more clearly. So the first example that I am taking here is, he gave the equation as y n plus 2 plus y n plus 1 plus 4y n plus 1 plus 4y, it's n, 4y n. Okay, for any problem given, we have to solve it in steps manner. So the first step that we are going to take here is, we have to take, in question he also given y1 as 0 and y0 as 2. So the first step in any question that he gives, the first step we have to do is take yn as lambda power n. So the first step we have to follow for any problem given is, we have to take yn as lambda power n. So we'll be taking yn as lambda power n. What will the given equation becomes? Lambda power n plus 2 plus 4 lambda power n plus 1, lambda power n plus 2 plus 4 lambda power n plus 1, and then plus 4 lambda power n. So in this we'll be taking common as lambda power n. By taking common lambda power n, we'll be having the expression lambda square plus 4 lambda plus 4 is equal to 0. Okay, is equal to 0. So we'll be solving this characteristic equation. This is known as characteristic equation. We'll be solving that. As we all know, how can we solve those power 2, that means quadratic equation, roots of quadratic equation, we'll be solving in the same way. We can also use calculator for solving this. So for this quadratic equation, we'll be getting two equal roots, that is lambda is equal to -2 and -2. We have discussed previously that if roots are equal, the solution will be yn is equal to a into lambda power n plus b into n into lambda power n. So we'll be having here two cases. As roots are equal, that is lambda is equal to -2, we'll put lambda is equal to -2 in above equation. We'll be getting this one. We'll be take that as equation 1. Now we'll be finding a and b, which are constant coefficients, and write the final recurrence relation. To find a and b, in question he given that y1 is equal to 0 and y0 is equal to 2. So we'll be keeping n is equal to 0 in equation 1. We'll get y0 is equal to a into -2 power 0, which is a, plus b into 0, which will become 0 overall. So y0 he gave as 2. So we'll be replacing y0 with 2. Then we'll get a is equal to 2. So he also given y1 as 0. So we'll be taking n is equal to 1 in equation 1. By solving that, we'll get b is equal to -2. Now, substituting a and b in equation 1, at last we'll get the recurrence relation that we need for the given problem. That is yn is equal to 2 into -2 power n minus 2 into n into -2 power n. This is the recurrence relation that we require. This is the scenario in which roots are equal. But what if roots are different? Let us take an example for that also. Here, the given expression is an is equal to minus an minus 1 plus 4an minus 2 plus 4an minus 3. He also given a0 is equal to 8, a1 is equal to 6, a2 is equal to 26. Now we'll be solving this. What I have said, I said that for any given problem, we have to take an is equal to, or in previous problem it's yn, so we have taken yn as lambda power n. Here it's an, so we'll take an is equal to lambda power n as first step. Okay, an as lambda power n. As I have solved in the previous problem, we have to solve it in the same way by taking an as lambda power n, and in place of an minus 1, we'll be getting lambda power n minus 1. By taking lambda power n common from all those, we'll be getting the final equation as, or characteristic equation as, lambda cube plus lambda square minus 4 lambda minus 4 is equal to 0. So we'll be solving in synthetic division method, or you can use calculator to solve this cubic equation. At last we'll get roots as lambda is equal to -1, +2 and -2. Here all three roots are different. So in this scenario, we'll be taking final recurrence relation equation as an is equal to a into, this is lambda 1, and the multiplication of b, this is lambda 2, and this is lambda 3. So we'll be substituting lambda 1, 2 and 3. We got equation as this. So here we have to find a, b and c. So for that, in question he gave a0, a1 and a2 values. So we'll be keeping n as 0 first, and then n equal to 1, and then n equal to 2. We'll be getting the respective equations as 1, 2 and 3. By solving all these three equations, we'll be getting a as 2 and b as 5 and c as 1. So by substituting all these a, b and c values in equation 1, we will be getting the final recurrence relation. So in this way, we will be solving every problem that is given. So for every problem, the first step is to take an is equal to lambda power n, and take common, whatever the common terms are there, we'll be taking that and solving that characteristic equation, finding its characteristic roots, and if the roots are equal and if the roots are different, I have given already the formula which we have to use. So by using those, we can find recurrence relation for any given problem. So this is the end of the topic, solving homogeneous recurrence by using characteristic roots. So thank you.